Cambridge International AS Physics May-June 2020 Paper 22 Solutions for Question 1 to 3. Question 1. Define velocity. Since it is 1 mark question, you can write the word equation of velocity. That is, velocity is equal to change in displacement over time. Or as a sentence you can write down, velocity is the rate of change of displacement. Part B. The drag force Fd acting on a car moving with speed v along a straight horizontal road is given by the drag force Fd is equal to v square ak, where k is a constant and a is the cross-sectional area of the car. Determine the SI base unit of k. So here in this question you have to find out the base unit of constant k. So in order to find the base unit, the first step is you have to rearrange the given equation in terms of k, because you need to find out the base unit of k. So the equation given is the drag force Fd is velocity squared times area of cross section times constant k. Now we can rearrange the equation and you can make k as the subject. So k will be equal to Fd, that is the drag force, over v squared times a. When you take v square a to the left, it will go to the denominator. Now we can find the SI base unit of each quantities at the right hand side of the equation. At numerator, Fd, that is drag force, so that it is force, and F is ma. So you can even write down, instead of force I can write ma over velocity square times area of cross section. Now what is the SI base unit of mass? It's kilogram. And SI base unit of acceleration, meter s raised to minus 2 over base unit of velocity, meter s, but s raised to minus 1, that is the base unit of velocity, but here it is velocity square. So you have to whole square the unit of velocity times area. The unit of area is meter square. Now you can take the square inside. So you will get at numerator there is no change. It will be kilogram meter s raised to minus 2. But at denominator, when you take the square inside, meter will become meter square. S raised to minus 1 into 2, it will be s raised to minus 2 times m square. Now you can combine the m squares because there are 2 m square at the denominator. So you will get kg m s raised to minus 2. At numerator there is no change, over there are 2 m squares, m square and m square. So you can combine these. So you will get m raised to 4 and s raised to minus 2. Next step is you can take whatever given in the denominator, or whatever you have got at the denominator you can take to the numerator. So already kg m s raised to minus 2 is there at the numerator. Then this m raised to 4, when it coming to the numerator it will become 10 m raised to minus 4. Likewise m raised to minus s raised to minus 2 will become s raised to plus 2. Now if there is anything common you can combine. Kg is only 1, so you can write kg. But for m there are 1 m is there and m raised to minus 4 is there. So when you combine you will get m raised to minus 3. And this s raised to minus 2 and s raised to plus 2. So it will become s raised to 0, that is 1. So the second or s unit will cancelled. So this is the SI base unit. So you can write down kg m raised to minus 3. Even though if your final answer is wrong, if you have identified that Fd is drag force but it is simply force, that is ma, so that if you are writing that force is kg m s raised to minus 2, you will score 1 mark. Question number 1 part C. The value of K in SI base units for the car in B is 0.24. So this is nothing but the drag force which is given. The cross-sectional area A of the car 5.1 meter square. Cross-sectional area is also given. The car is traveling with a constant speed along a straight road and the output power of the engine is 4.8 into 10 to the power 4 watt. Assume that the output power of the engine is equal to the rate at which the drag force Ft is doing work against the car. Determine the speed of the car. So in this question, they have provided the drag force value, that is 0.24, and the area of cross section of car and the power of the engine. And you need to find out the speed of the car. So in this question, power is given and you need to find out velocity. So which equation relates power and velocity, or power and speed? So if you know that power is actually work done over time, and what is the equation of work done? Work done is nothing but force into distance. Then there is over time. Now look at the equation F times d over t. Now what is this distance over time? It's a very important equation in physics, that is distance over time is nothing but speed. So that you can write down the same equation, F into velocity or speed is power. So this is also another equation of power other than work over time or energy over time. That is, power is the product of force into velocity. Now you have to find out velocity. So you can rearrange the equation so that you will get velocity is nothing but power over force. But in this question they have mentioned, assume that the output power of the engine is equal to the rate at which the drag force Ft is doing work against the car. So you can consider this force is equal to the force exerted by the engine will be equal to the drag force Ft. And we already have another equation of drag force Ft which is given in first part, that is Ft is equal to V square times Ak. So in the same equation, instead of Fd, you can write the equation given in first section, that is Ft is equal to velocity square times area into constant K. Sorry, in the question this 0.24 is not Fd, but it is the value of K, that is the constant K. So now I am again writing this equation, that is we got velocity is equal to power over velocity square times A into K. So there are velocity at RHS and LHS. So I am going to take the velocity from this denominator to numerator. So we will get V cube is equal to power over area of cross section into constant K. Now we have all the value, you can directly substitute. Power is 4.8 into 10 to the power 4 over area of cross section is 5.1 times constant is 0.24. So you can take the cube root of this value. So you will get V is equal to 34. So the answer is 34 meter per second. Now question number 2. Figure 2.1 shows the velocity time graph for an object moving in a straight line. Determine an expression in terms of u, v and t for the area under the graph. So in order to find the area under the graph, you can, since it is not a triangle or a rectangle, the easiest way is you can divide it into two parts so that you will get one rectangle and another triangle. This section represents rectangle and this section represents triangle. So you can find the area separately and you can add. That will be the total area under the graph. So that is the area of rectangle plus area of triangle. Let's check area of triangle. As you know, it is length into breadth. Here, the length is, we can consider this one, that is u, height is u, times breadth is t. So you will get u into t, that is ut. Likewise, the area of triangle, half into base into height, where half into base is t, it's again t, as you can see. But what is height of the triangle? Height of the triangle is this height. So this height will be same as this height, and this value is, this length will be v minus u. So in the equation, instead of height, you can write down v minus u. Now the total area of this graph will be the sum of these two. So you will get area is equal to the area of the rectangle, that is ut, plus area of the triangle, that is half into t into v minus u. So this is the area. So as they have mentioned in the question, in the equation of area, we have u, we have v, and we have t. And it is a very easy question, and you will get only 1 mark. And the second part of the same question, that is, state the name of quantity represented by the area under the graph. Look at this graph. This is a velocity time graph. So if you have a velocity time graph, area under the graph will give you the displacement. Likewise, the gradient of velocity time graph will give you always acceleration. This is very important. So now you have calculated area. So which quantity represented by area? As we have already seen, area represent displacement of the object. So you can write down displacement. Part B. Part B is from the topic projectile motion. A ball is kicked with a velocity of 15 meters per second at an angle of 60 degree to horizontal ground. The ball then strikes a vertical wall at the instant when the path of the ball becomes horizontal, as shown in the figure. Assume that the air resistance is negligible. By considering the vertical motion of the ball, calculate the time taken to reach the wall. So you have to calculate the time, how long it will take to reach the wall, and you have to consider only vertical components. So we can check what are the vertical components of velocity: initial velocity and final velocity. So vertically, initially it will be vertically upward, and the angle 60 is given here, so that the vertical will be, you can use the equation velocity times sine theta. Here they have given the vertical velocity, that is 15 times sine 60. So this is initial vertical velocity. So you can represent uv. So uv is nothing but 15 sine 60. Okay. Now, when the ball hits the wall, what is its final vertical velocity? As you know, in any projectile motion, when the object is at the maximum highest position, its all velocity will be horizontal velocity. The vertical velocity of the ball will be 0. So that the final vertical velocity we can represent it by Vv, always at the top of a projectile motion will be 0. Now we have uv, we have vv, and for a projectile motion, this is falling or moving under the gravity, so that there will be always downward acceleration, and that downward acceleration is g. You can consider as 9.81, but when the velocity, when it is moving upward, we have considering it as a positive sign, and g direction is always towards ground. Acceleration due to gravity is always acting towards the ground or down. So that this one you have to take negative sign. So this is acceleration due to gravity. And you need to find out time. So you can use any of the SWOT equation. We have initial, final velocities and acceleration. So you can find out uv as we discussed. It is 15 sine 60. So you will get 13 meter s raised to minus 1. And final velocity vv is equal to 0. And g value is minus 9.81. You need to find out time. So you have to choose which SWOT equation you have to use, where you don't have displacement. So here you can use the equation v is equal to u plus at. Now you can substitute the values, and here as we are considering only vertical, everything you can write down vv. Even a also we can change, since this acceleration is acceleration due to gravity. So you can even put gt. Now you can substitute vertical velocity. Final vertical velocity is 0. Initial vertical velocity we have calculated 13 plus g value is minus 9.81 times time t. Now you need to find t. So you can make t as the subject. So first I am going to take this whole thing towards LHS. So you will get this minus 9.81 will become plus 9.81 times t is equal to 13. So the time will be 13 over 9.81. And you will get a time 1.3 second. That means the ball takes 1.3 seconds, second is already given, to reach from the ground to the wall. Let's go to part 2. Explain why the horizontal component of the velocity of the ball remains constant as it moves to the wall. So again we can go back to the picture, and here it says that the horizontal component of the velocity remains same, or it's constant. That means we have calculated the vertical component. Likewise, initially we can even calculate the horizontal component of the velocity, and it will be, we can represent it as initial horizontal component UH. That is, the equation is U cos 60. So 15 cos 60, and 15 cos 60 is 7.5 meter s raised to minus 1. And this horizontal velocity will be same throughout the motion. Anywhere you consider, if this is 7.5, that is the horizontal initial velocity. If the ball is somewhere here, if you check, its horizontal velocity will remain same. That will be at this moment again same as initial horizontal velocity. Even at the top height, we have seen vertical velocity will be 0, but the horizontal velocity at the highest position will be same as the initial value. So everywhere in a projectile motion, the horizontal velocity remains same, not like vertical velocity. Why it is so? That is the question. The reason is, as they have mentioned, air resistance is negligible. As air resistance is negligible, there is no horizontal force in any direction acting on the ball. There is only one force acting on the ball, that is the force due to gravity, its weight, or force due to gravity. That's why there is a acceleration downwards. But horizontally there is no force, so that horizontally there is no acceleration. As long as there is no acceleration horizontally, the speed will be constant. So when you consider horizontal motion, the important points you have to remember. The first point, no force acting horizontally. If in the question it's mentioned that air resistance is negligible. In most of the projectile questions, the air resistance will be negligible. So the first point should come into your mind when you consider about the horizontal motion is that there is no horizontal force. So that there is no horizontal acceleration. Hence, horizontally, speed or velocity will be always constant. Okay? But you should keep one point very important, that this is only about horizontal motion. Vertically, there is a downward force acting. So, it is for vertical case, it is different. So, since it is only 1 mark question, you can write down. The reason is force in the horizontal direction is 0. Part 3. Show that the ball strikes the wall with a horizontal velocity 7.5 meter per second. So we have already seen horizontally everywhere the velocity will be same, that will be 15 cos 60. That will be 77.5 meter per second everywhere. So even when the ball strikes on the wall, its horizontal velocity remains same as the initial horizontal velocity. Horizontal velocity, as we have mentioned, it will be constant throughout the motion. So horizontal velocity of the ball when it is reaching at the wall will be same as its initial horizontal velocity, and that equation is u cos 60 and u is 15 cos 60. Hence the answer is 7.5 meters raised to minus 1. See, the mass of the ball in B is 0.40 kilogram. It is in contact with the wall for a time of 0.12 seconds and rebounds horizontally with a speed of 4.3 meter per second. Use the information from B3 to calculate the change in momentum of the ball due to the collision. So here, the ball, it hits the wall and it rebounds, and the velocity of the ball before it hits we have calculated in the previous part, as at the top of the projectile motion, all its velocity will be horizontal velocity, and which we have calculated, that is 7.5 in our previous part. So the velocity of the ball when it hits it's 7.5. And in this question, the velocity of the ball after it rebounds is also given. That means the velocity after rebounds. So we can represent as it is V, 4.3 meter per second. The mass of the ball is also given, that is 0.40 kilogram. You need to find the change in momentum. As you know, change in momentum is the difference in initial momentum, that is momentum equation mass into initial velocity, minus the momentum of the ball after rebounds, which will be mass into final velocity. We have everything. So I am taking V outside, so you will get m times u minus V. You can substitute everything, that is mass is 0.40 kg. Initial velocities we have calculated in the previous part, and final velocity or the velocity after rebounds is given in this question. So just substitute. But here you have to be careful. The velocity must be minus when it rebounds, because its direction is opposite. So you have to put minus value. So here is also minus 4.3. As initial velocity u, when it is towards right, if you taking positive, the velocity of the ball after it rebounds, as the direction is just opposite, you should put minus. So it will become minus of minus 4.3. So you will get 0.40 times 7.5 plus 4.3. This is something very important. You have to be always careful. When the velocity changes its direction, you have to put negative, and the other direction you should take positive. So you will get the answer as 4.7. Next question, calculate the magnitude of the average force exerted on the ball by the wall. So here you have to find out force. In the previous part, even they have given the time taken by the ball to return, or the time of contact is given. So we have the change in momentum which you have calculated, time you have, and you need to find out force. So which equation relates force, moment, change in momentum and time? That you have to use the Newton's second law equation, that is force is equal to rate of change of momentum, where delta P you have calculated and time is given. So you can substitute it. Delta B is from the previous part 4.7 over time is 0.12. Hence the answer you will get 39. So 39 Newton is the answer. Next, question number 3. Part A. Explain what is meant by work done. It's a 1-mark question. So again you can write down the word equation of work done. So work done is equal to force into displacement in the direction of force. That is very important. You should write down the displacement in the direction of force. That means if you have an object and if you apply a force, and so because of this force, if the object displaced a distance of x meter, then the work done will be the applied force times the displacement x. But here one important condition is the direction of force and the displacement both should be in the same direction. Part B. A ball of mass 0.42 kilogram is dropped from the top of a building. The ball falls from the rest through a vertical distance of 78 meters to the ground. Air resistance is significant so that the ball reaches constant terminal velocity before hitting the ground. The ball hits the ground with a speed of 23 meters per second. Calculate the ball falling from the top of the building to the ground. The first one, the decrease in gravitational potential energy. So in this question, we have a ball which is initially at rest and which is 78 meters above the ground. So the height is 78 meter. Mass of the ball is given, that is 0.42 kilogram, and because of the air resistance, after traveling some distance, the ball reaches its terminal velocity. So we can consider this is the point where the ball reaches terminal velocity. Terminal velocity means its upward and downward forces will be same, so that from there onwards there is no acceleration. So constant velocity. So this is the point if the terminal velocity started mean from here everywhere the velocity will be same, and which is given, that is 23 meters per second. That means in the question it says the velocity of the ball when, or the speed of the ball when it reaches the ground is 23 meters per second. But as you know, the ball has already reached terminal velocity. So everywhere at terminal velocity, the ball speed will be 23. That is what you have to understand. In the first question, you just need to calculate the gravitational potential energy change, decrease. So the change in the potential energy will be equal to mg into change in the height, that is mg delta h. So we have all the values. Mass is 0.42 times g value is constant, which is 9.81 times change in height. The height of the ball from its initial position to the ground is 78. So just find the answer. It will be 320 joule. So the answer is 320. So the potential energy of the ball when it was at a height 78 meters above the ground, its potential energy was 320. But when it is reaches the ground, as you know height is 0, its potential energy will be 0 joule. So the potential energy changed from 320 to 0. Next question. You need to find the increase in kinetic energy. So here you know the ball when it is reaches the ground, its velocity is given, that is 23 meter per second. So if you know the velocity and mass is also given, you can find the kinetic energy. So the kinetic energy equation, kinetic energy is equal to half mv square. So half into mass of the ball is 0.42 and velocity is given, that is 23, because it's given when it reaches the ground its velocity is 23. So 23 square, and you will get the total kinetic energy or the kinetic energy gained by the ball when it is reaches the ground is 110 joule. So what can you understand in this figure? At the top, the potential energy was 320, but what will be its kinetic energy at the top? Since it is at rest, the velocity is 0, so the kinetic energy of the ball at the topmost height will be 0, but when it falls down, its speed will increase, so that the kinetic energy will increase, and at the bottom the kinetic energy due to the speed 23 meter per second we have calculated. At bottom its kinetic energy is 110 joule the moment it touches the ground. Next question. Use your answers in B1 to determine the average resistive force acting on the ball as it falls from the top of the building to the ground. So you have to check the answer in previous part and you have to determine what is the average resistor force acting on the ball as it is falling. So it's already mentioned there is air resistance, so there will be a resistive force. That's what you have to calculate. So in this question, you need to calculate when the ball is falling towards the ground, how much is the average resistive force acting on the ball. The resistive force will be always opposite direction of the motion. So the resistive force will be always upward. In this case of the motion of the ball, you need to find out this force. So here we have some values which is related to energy only. From energy, how can you find out resistive force? So again we can look at our example in this question. Initially the ball was having potential energy of 320 joule. Out of that joule, only 110 joule is gained by the motion or kinetic energy. So what happened to the remaining energy? That is, from 320, only 110 is converted to kinetic energy. So the remaining energy is wasted as a form of heat because of this resistive force. So we can calculate how much has the energy wasted. So you can do it by just subtracting the total potential energy minus kinetic energy. So you will get the energy wasted used to due to friction or due to the resistive force is the initial potential energy minus final kinetic energy, because all of its potential energy has not converted to kinetic energy. So that means the remaining energy has wasted in the form of heat, and it is only due to this resistive force. So we have the values, you can substitute. So you will get 320 minus 110. So you will get 210 joule. That means the air which has to, or the resistive force has to do a work equal to 210 joule. So the work done by the resistive force will be equal to the energy wasted by the ball in the form of heat, and which we have already calculated 210 joule. Now you can use this equation, that is work done is equal to force into displacement. So here we have work done, that is 210 joule, the work done by the resistive force. It will be completely the energy wasted. So that is 210 is equal to the resistive force, which we don't know, we need to calculate, times the displacement of the ball. That is the total displacement of the ball from the top position to the ground, which is 78. Now in order to find force, you can just rearrange the equation. So you will get force is equal to 210 over 78. And you will get an answer of 2.7 Newton. So that the average resistive force is 2.7 Newton. Next part C. The ball in B is dropped at time t and hits the ground at time t. The acceleration of free fall is g. On figure 3.1, sketch a line to show the variation of the acceleration a of the ball with time t from time t is equal to 0 to t equal to 1. So in this question you have to draw a acceleration time graph. As you know, the ball is falling downwards. Initially its acceleration is equal to g, that is 9.81, because there is only one force acting, that is its weight, which is acting downwards. But as the presence of air resistance, while the ball is falling downwards, weight will be again acting downwards, but there will be a resistive upward force which will keep increase. So as the ball falls down, air resistance, which is the opposing force, will keep increase, so that the resultant force will reduce comparing to the previous position. So this is, let it be the resultant force. Now when the ball reaches at the terminal velocity, its downward weight must be equal to the upward air resistance. In that case, there is no resultant force. F net acting on this ball is 0, because downward weight is equal to upward air resistance. So in this case, net force is 0. At that position, acceleration is also 0. Then here the ball has reached terminal velocity. So this is what will happen to G. Now at initial position, G is 9.81, but when it is falling downwards, as the air resistance increases, as the resistive forces increases, net force is less. So the acceleration will be something lesser than G value 9.81, and when it is reaches the terminal velocity, that is almost at the end of its journey, its acceleration will become 0. So you have to draw a graph to show this. So the shape of the graph will be, it should start from G, because initially there is only its weight, so there is only acceleration due to gravity, that is 9.81 at the initial position. So it should start from G, but it should gradually decrease. So this must be the shape, and even before reaching the final time, its acceleration will become 0. This part is very important, as it reaches terminal velocity means there is no net force. So this point represents the terminal velocity reached. You can find the link for the solutions for remaining questions in the same paper in the description. Thank you for watching the video. If you find it useful, please subscribe my channel and like this video. Thank you.